Hello, I've had a question in Unit 4, Lesson 6, and this is the second part of the homework, Part 2, question 43. It wants us to find a point on the line which is closest to the origin. So if I draw myself a bit of a graph, here's the equation in question, 3x plus 4y equals 25. So what I want to do is I want to get an accurate sketch here, so I'm going to rearrange it to get y equals. So it's a little easier for me to graph. So negative 3x plus 25, and we divide everything by 4, and we get negative 3/4 x plus 25 over 4. So there is the equation of the line in question. So 25 over 4, it's roughly, what, 6.5, somewhere in there. Anyway, let's say it's right there, the y-intercept, it's negative, so roughly there's my line. The question wants us to know what's the shortest distance from that point to the line. And it's always right angle when you're looking at closest distance, shortest path, it's the closest point there. So this is what we're looking at right here, that length right there. So we want to optimize our length, and we have two components here then. We have, if I break it into a right angle triangle, this coordinate is x and y. So this distance here is x on that side, and this is y. So that means we are trying to optimize the hypotenuse of a right angle triangle. So our optimization equation, so we're trying to optimize the hypotenuse. So that means we have L squared equals x squared plus y squared. Alright, so I want to do it in terms of one variable, so I either have to pick x or y, and if you look here, when we rearrange the equation here to get y equals, we have y in terms of x, so we can use that in our optimization equation. So this turned out to be our constraint equation as well. So we end up with L squared equals x squared plus bracket negative 3/4 x plus 25 over 4 squared. So now we can take the derivative of that length with respect to x, and we get 2x plus 2 bracket negative 3/4 x plus 25 over 4 to the exponent 1. Then we have to take the derivative of what's inside. So inside it would be just negative 3/4, since 25 over 4 is a constant. So now we can simplify, and we do that by saying, well, let dl by dx equals 0. 0 equals, cleaning this up a little bit, 2x. Now this term here, right there, it's just the exponent 1, so we can use distributive law. So I'm going to distribute negative 3/2, and that's because this 2, the negative 3/4, will result in negative 3/2. So I'm going to distribute that in. So negative 3/2 times negative 3/4 will give me positive 9/8 x, and minus 3 times 25, so that's 75 over 8 as well. So we can rearrange. So the 75 over 8 goes to this side, and well, we have 2x plus 9/8 x. That's like saying 16 over 8. So that's going to be 25x over 8. 8's cancel, and we get x equals 3. So now we can plug that in to get our coordinate. So, finishing this off, y equals negative 3/4 times 3 plus 25 over 4. So we get negative 9/4 plus 25 over 4. So that's 16 over 4, or also 4. So therefore, the closest point is 3, 4. Alright, anytime you have a constraint equation involving the equation of a line or parabola, it's the same process. It's always Pythagorean theorem that you're optimizing, and the equation the equation itself is what is your constraint equation. So if you have any questions, let me know, and I'll try to help you out.